Okay, hi. I'm Dave. I'm a Hackaday writer, and I'm an engineer. Strangely enough. Any more engineers in the room? Woo! Yes, everybody, I know. So, in the beginning, we all start the same way, right? You go to college, we go to school, we learn our craft, we headbang a few screens in our youth, getting very angry about coding problems. You know, I'm no different. So, I'll give you a bit of a background to how I started, which will make sense as we move on through the presentation. So I started working for Philips Semiconductors, which was conveniently near where I was, working on digital TV, around about the time the Twin Towers came down, which was pretty sad timing. But it gave me a good grounding in embedded programming and not a lot of electronics, though. So I kind of thought, hey, programming is kind of fun, but I'm not using my degree here at all. But luckily, they had a plan. Redundancy. A typical story about any company, a large company, is that nothing ever changes, stays the same, change is constant, and you better hope your skills fit what they want next. So, I made a big move. In the UK, I don't know if it's the same where you're from, but in the UK, over a certain number of redundancies, they have to open it up to everybody to offer that they want to take one of those slots. And luckily for me, somebody did. So somebody in the IC test and manufacturing support group wanted to leave. So I just took his job. So what was I doing? I was supporting, have you ever heard of an AT, or the big iron? Do you know what an AT tester is? For IC design? Manufacturing, you need to obviously test each device as it comes off the production line. So you test at the wafer level, you also test at the package level, potentially, depending on the product, how it's going to be used, and whatnot. And these machines they're very big, they're very expensive, they're very complicated, and very specialized. So I wasn't actually programming these, I was only supporting the guys who was, but I was on taking all the training courses and learning the ropes as I went along, watching their mistakes, and generally doing all the fun little jobs. Top left there we have ChatGPT's interpretation of what I asked for, which was an ESD bunny suit. It's close, but it's not really what I had in mind. So, as you do, you find another job, because things were looking a bit ropey again in Philips. People were moving around strangely. So I jumped ship to a US-based fabless company based up in Camarillo. You may know them. And they wanted to employ me as an actual, real, full-blooded test engineer. Woo! Sounds exciting. It's not. But it's great money. Anyway. Moving on a little bit. There was a chance meeting with the chief executive, and he came barreling into the room, and he was talking about the royalty program. The royalty program is only open to developers of the chips, the IC design group, not the test department, despite the fact that we sweat blood constantly to put these chips out there. We're not invited. And he said, if you want a taste of the royalties, go ask HR to move into design, half laughing. So I did. Not forgetting, electronics engineer, I've studied all this thing, I can just move, and so I did. And this was a great move. A few years designing ICs, mostly for the digital side of things, working on some fun projects, lots of FPGA prototyping. As we go along, gathering more skills, so bearing in mind now I've touched embedded, I've touched now PCB design, I've touched IC design and FPGAs, really grew up getting a great grounding in engineering that just pure circumstance. No plan whatsoever. And then I got laid off again. What was the guy to do? He's sitting in my workshop thinking, what the hell am I going to do? There's no jobs in this industry in the UK. I know, I'll work for myself. Who needs a career? So it turns out that building a business in the UK or anywhere else is really damn complicated. There's so much that has nothing to do with what you actually want to be doing. You're worrying about things like banking and marketing and advertising and building a website and being compliant with Companies House, whatever the equivalent in the US is, I do not know, but they're just as much of a pain in the ass. And yeah, but it's a necessary evil, right? I was working with innovation companies because for some reason they were really interested in me. I don't know why. I later found out that these guys, they sell their services to people on the street who come in with an oddball idea saying, yeah, we can take your $5,000 for some 3D slides, for some 3D renderings and maybe a vague business plan, but they don't have any engineering stuff. They're all industrial designers, patent lawyers. And every company I talked to was the same. They didn't have an actual engineer on staff. And they would outsource those bits to me and some of the people like me. And this was fine for a few years until I realized that I don't have a portfolio because I've signed about 15 non-disclosure agreements with all of these companies, which forbid me from even talking to anybody, including you guys, about anything I've been spending the last 5 years building, which is some pretty cool stuff. But I can't tell you what it is. Also, finding new business is hard because the word of mouth is pretty much the only way of doing it. And, you know, your portfolio is your advertisement. And if you don't have that, how do you get more business? So I just developed for a little while, building some kitting out my workshop, just doing the same sort of thing, thinking, I'm not doing very much here. It's not very exciting. Doing a few simulations, doing a lot of CAD, building a few small products, little PCBs, little trinket stuff. Because people that come off the street, they don't have big visions. They just have a very specific requirement, something very small. And I thought, looking at all the guys were doing when I was walking around their workshops, thinking, they're just running 3D printers a lot. I've got 2 of those. And they got a milling machine. There's one in the local hackerspace. And they got a laser cutter, one of those too. And actually, what are they really doing that I can't do? And I began thinking, actually, even with the electronics, there's still a ton of things to think about. And you must really love it to want to stay in that space. And I'm not sure I entirely do. Because I'm in a sort of self-contained box. You start off, you get a degree, and you have some initial experience, and you kind of end up doing the same old things. And I was speaking to some innovation guys, and they were saying, oh, that's the PCB guy. And I'm thinking, I'm just a PCB guy? But I can do more than just PCBs, right? I mean, how hard could this stuff be? So after a few years thinking, I'm kind of stagnating here. My knowledge is limiting. It's not developing in any way. And of course, I've got no portfolio. This was really annoying me. I designed many PCBs. Many, probably a couple of hundred. And I'm just thinking, I don't want to be a PCB guy. I want to do it all. I built some art installations. I built an arcade machine for the kids just because they asked for one. Who could say no? And I built all my old tools and some test equipment and various things. So I got a bit of experience putting together physical things, mechanics and 3D printing and those sorts of assemblies. Just get out of the box. Crawl out of the box. Fight our way out of this box. Then strangely enough, luck jumped on me again after all these setbacks. Some guys wanted me to build something, and it was totally oddball. They wanted to put an airbag in a basketball shoe. And then I was walking around the New Forest, walking my dogs at night, because they're US-based, listening to what they were saying, and he was very, very keen. He was very, very insistent. And I was saying, I'm just an electronics guy, but I don't really... Can't you talk to an innovation company? Ha. Oh, you don't like those guys, was the response. They take too much money. They don't do much work. I didn't tell them that. They obviously figured it out themselves. Maybe they got burned. Who knows? So what is this, and why would you want to do it? So top left was my specification. They'd employed a 3D designer to sort of mock something up. And they said, go and build that. How hard could it be? It's not very easy. So I bought a shoe and had a look at it and thought, I have absolutely no idea how to build that. It looks simple and innocent enough. It isn't. There's all sorts of things going on in there. So the concept was pressure sensors in the foot, detect the roll of the ankle, and deploy a bag fast enough to correct the posture. So your hamstrings and whatever the tendons down there are don't get overstressed. So basketball players get benched quite a lot. Apparently it's really bad news. These ankle rolling injuries can bench a player for months, and that's big business in the US. So that's why they were very keen. And I just couldn't shake them off. Then we talked about the airbag. I mean, how do you deploy an airbag? What's an airbag? It has explosives in it. Explosives in shoes. Did they not remember that shoe bomber guy? But I still couldn't shake them off. They kept coming back. We want to pay you to do a feasibility study. Okay. If I want to break out of the box of being just a PCB guy, maybe this is it, I thought. Why the hell not? Would be pretty awesome if I can pull it off. I'm still not sure I can. You see, this is an ongoing project. This is actually my current project. This is my only project that's my business is working with right now. I'm not doing anything else. It's pure research and pure playing around. And of course, there's no damned NDA. I can say what I like. So I'll show you the guts of the thing. I hope I'll not be over too much time here. What's an airbag? We know what an airbag is. It's that thing that shoots in your face when you're unfortunate enough to hit a wall or another car or a cow or whatever happens to be in your path at the time. And that thing is explosively, it's a hot gas generator, essentially. It's an explosive in a box that inflates a bag, and then the bag deflates hopefully fast enough so you can escape. And they were saying, yeah, like those ones. What, like the car ones? Yeah, like the car ones. But what about the bike ones in the middle, which have a nice CO2 gas canister in, and they just install a little bit less explosively, but still very rapidly? Could we not use those? No, they're not fast enough. So they've obviously thought about this. And I threw the Honda Goldwing airbag in for a laugh, because it's just silly, isn't it? And of course they wanted to make things even more entertaining. Oh no, we're not building a prototype. We're building a startup. And you're the tech. You're the only guy, because we can't afford anybody else. So then the mind map comes out. We start brainstorming and breaking down the problem into, oh look, it's lots of tiny little projects all rammed together, half of which I have absolutely no idea how the hell I'm going to do. So I'm thinking, right, well, this is my box over here. Let's concentrate over here. Let's just go for pain. Just go for everything I can't already do and just get on with it. So I started ripping things to pieces. This is the inside of a bunch of airbags. I bought them on eBay. I'm not joking. Apart from the bottom left, which was from a breaker's yard, that's obviously been deployed. I wanted some that have been deployed and were safe, and some that had not been deployed and are not safe. So this is one out of a Porsche. Looks a bit like a little burrito. It's quite neatly wrapped, very German engineering. And I started studying the materials and the stitching patterns and how the whole thing is held together. There's a lot to learn from these things, because no one wants to write it on their website. Have you ever seen the teardown of an airbag written up by Hackaday.io? Probably not. Probably for good reason, because they're not very interesting. Anyway, I extracted as much detail as I could from this. I'm very over. Oh, so we have two types of airbags to make life all more very interesting. We have the hybrid at the top, and we have the gas generator, the hot gas generator at the bottom. This is what's in your steering column. This is what's in your side airbag. The top one has pressurized argon in it, and it's explosively initiated by a primary explosive here. And the hot and cold gas streams mix so you don't freeze. The bottom one, they just hit you with hot gas in the face. Then I had a chat with an explosives expert, as you do. There's a bunch in the UK. And he said, I reckon all we need is what's at the top. We'll get one of our pyrotechnic squibs, which are like an explosive initiator, electrically initiated primary explosive, in a box. And we'll put a couple of filter gauge, a booster charge behind it, a couple of filter gauzes, and a heatsink around the outside. That's my mock-up. And then he stopped talking to me. So plan B might well be the CO2 stored gas option after all. But CO2 in small containers, do you know what pressure they run at? Well, 800 to 900 pounds per square inch, or about 50 or 60 bar in US. What does a typical solenoid run at? Half a bar. Great. So anything I want to use doesn't really exist. Moving on, let's learn to sew. Didn't get taught sewing at university, and my mum wouldn't let me try, which was very unfortunate because I actually did want to learn. Anyway, so I bought a sewing machine on eBay, like you do, used for making sales and things, and had a go at sewing a little bag shape out of some material I found also on eBay, which was another mistake, because that is parachute nylon used by the British Army, and it's literally cut-offs of their parachute, which has been sold on eBay spare parts. So I managed to make some sew, but you can see it ripping and tearing, and it makes a horrible mess. So turns out sewing's hard. Who knew? There's so many things to think about with these materials, the thickness, the denier, the thread types, whether they're bonded, unbonded. It's a whole sub-project in itself, ongoing. Moving on, let's take a shoe apart to see how it works. Well, firstly, it really stinks using hot air to disassemble a shoe, but you can get away with it real quick. So there's the sole, there's the upper part. I studied the stitching patterns and how they went together, the different segments. So moving on from that, because it's not very interesting, but the top thing I tried to 3D scan. Because I'm lazy like any good engineer, I do as little as possible. So, Meshtastic looks fun. I just looked on Hackaday to see what we were going to use. And Meshtastic popped up, and it made a horrible mess. So it turns out 3D scanning's harder than I thought too. Who knew? So that's another little sub-project to move back to. Moving on, how do you make a sole? Some guys have 3D printed them. We covered these on Hackaday loads of times, 3D printed insoles, and good. We could do this. I could definitely do that. Just buy some Ninja Flex, whack it in the printer, off we go. No, I talked to a 3D printing expert. He said that's probably not going to work with the thickness you want. You want to cast things in rubber. Have I ever cast things in rubber before? No. So, turns out, as you've heard before, that silica molding is great because nothing wants to stick to silicone except more silicone. So I use polyurethane. So the quick test with a 20p piece, can I cast some rubber in rubber? Yes, it's good. But feet are quite big. And we'll come on to why in a minute. This is a bit of a problem because I wanted to use resin printers or any other printer I could find to print molds to cast rubber into. And all of the available commercial curing machines are too small. So I built one out of scrap. These are the UV lamps out of a 3D printer that was someone gave me that was spare. I built a casting box by just copying the design of YouTube because, don't want to make stuff, just copy things. So I got all the pieces I need, and I had a little go at casting because we can't use a single-sided cast. No, that's far too simple. The shape is too complicated. We have to use a double-sided cast. So we have to make two mold halves that are registered together and somehow get the rubber in there and make it follow the right shape. So I 3D printed a master. I sealed it. I made a little bed for it of polymer clay, and it cannot be ordinary clay because ordinary clay contains sulfur, and silicone will not cure in the presence of sulfur. Yet more damned learning. Luckily, someone in my hackerspace said, don't let sulfur get near it or it won't cure. She was right. She didn't have a deep voice. I asked her to what. So I made the bottom part of the mold here. These are registration marks, which you make by just sticking a pencil in there. Extract this, clean it up, add some sprues. It doesn't want to change to the next page. There we go. So I made these two little mold halves. This is just a real quick test understanding. Injected with the syringe, the rubber inside. Oh, I put the sprues in the wrong place. There's massive air bubbles. It looks horrible, but it's workable. Can I copy a shape from 3D printed master into rubber? Yes, I can. Skill unlocked. Moving on. Feet. The funny shape things. I thought, I looked on eBay. I need some feet for testing pressure distributions and shapes and casting. And you get all kinds of crap on eBay, right? These silicone things, they're hundreds of dollars. They're far too expensive. Like, that's half of my monthly budget for these guys because they are really tight. And these things on Amazon were, I don't know what they are. They're just cheap-ass mannequin feet. They're no good. They're no good either. But then I remembered, I've got feet. So somebody said, oh, you can scan your feet in a flatbed scanner because, as we know within inverse square law, the closer an object is to a light source, the brighter it appears. So sticking my foot in my scanner and stuffing a towel inside a box, I've got this horrible thing, cut the bottom of a box, stick a scanner inside, cut a hole on top, stick my leg in, stuff a little rag around it, make it nice and dark, try not to crush the glass while balancing at a very precarious angle using I think it was an analog engineering textbook as a counter to get in the right angle here. And I made a scan which looked okay. It looked good, and turned it into a false color map, and it sort of lines up with where the pressure regions are, which is where you'd expect. So you get pressure here, some pressure there, and the big toe. That's where your feet contact the ground. If that doesn't happen, you need to go see a podiatrist. I did all this in GIMP and Inkscape. No special tools for me. Remember this guy? I wrote this up a couple of months ago. This guy from Holland, he was on the Fab Academy course, which is run by one of the MIT professors. One of the Harvard professors. And he made this marimbatron with a recalibrated scale, but he made his own pressure sensors. And the little bell went, oh, something else I can steal. So one of the things that's great to do is learn from other hackers, learn from other disciplines, or just steal ideas. And all I needed was a vinyl cutter. So I've been acquiring tools, and oh, look, someone's selling one for £50. I'll have that, thank you. I got another tool out of it, and I started making some DIY pressure sensors following what Leo had done. It's super simple. It's so easy. The motivation for this is because whilst you can buy force sensing resistors, they don't have the load range, they don't have the shape, and making them custom shaped is so expensive. They wouldn't even give me a figure, they just said you can't afford it. Well, thanks. I'll make my own. How hard can it be? This is the mantra. How hard can it be? It's not hard, but once you try to make it into a product, it will be. But that's someone else's problem. So there are so many problems with this. This is where I am pretty much right now. Trying to use graphite as a piezo-resistive material on a simple electrode pair to make a directional force sensor, I'm going to call it. So I turned my foot map into a region of sensing regions as 8. These are probably superfluous, but in the heel, in the midsection, and in the toe. And the plan was to work out the angle of force and the rate of change of the angle of force based on the measurements from this and some calibration and an accelerometer, and use that, hopefully, to characterize the difference between normal basketball play and the bad ankle roll situation, whatever that may look like. Unfortunately, the company has failed to provide a budget for the past 4 months. So this is not where I wanted to be for you guys. I wanted to show you a lot more development, but with no money, it's very difficult to do that. So a bit more development. I thought, I can cast things in rubber, can't I? If I mix some graphite in, can I use that as like the force sensing component? All I need is like this graphite rubber and the electrodes, and I've got an instant pressure sensor. That must be so quick and cheap to make. It doesn't work. But I fixed it. You just spray it with graphite. And then, quick aside, because I like to play with things, I found in my stash a way of tinplating electrolysis. So I mixed that up and whacked it on the electrodes. I made a few distractions just to see if I could mask off some copper clad and make a sort of selective plating thing. I was going to make a badge this way, and it failed horribly. I don't know why. And finally, I've got a directional pressure sensor. It's not a very good sensor, but it works. So I built a data logger, because I don't own a data logger, because I'm too cheap to buy one, using an Arduino and a few components on our breadboard. And that is about as far as this project has got with the electronics, because remember, I'm not concentrating on the electronics, I'm concentrating on that other stuff that I can't do. So I guess, following my rambling story here, there's kind of a few points to finish on. Don't let your knowledge stagnate. Don't get siloed into a box. Get out of your box and try new things. Lots of ideas and techniques can be borrowed, stolen from other disciplines and people. Don't be afraid to try new things and see how they apply to your problem. It doesn't matter if you fail. And always have a plan B.